Hello wonderful person, this is Anton, and in today's video we're going to be continuing our discussion about the potential terraforming of the beautiful neighbor that we have right here, also known as Venus. Now this is often ignored in most scientific discussions, and also most sci-fi movies don't really talk about terraforming Venus as much as they do Mars. But we're going to focus on this because I personally think this is probably the best place for humanity to potentially call home in the future. Anyway, welcome to What the Math. In the previous part, we actually talked about changing the atmosphere of Venus, and we also talked about various chemical techniques and other scientific techniques we can use to try to basically remove the vast majority of atmosphere here, exposing the surface of Venus. If you do want to know more about it, watch the previous video, but here we're actually going to be talking about something different. Venus has another problem for us, and this is actually something that we need to fix for us to create a terrestrial planet with habitable conditions. Venus has very slow spin. So let me just actually remove this for a second. It spins extremely slow. A single day on Venus is equivalent to approximately 243 days on Earth. Because of this, there are two problems. One is that a single side is exposed to the solar radiation for about basically over 100 days, and then the other side is exposed to the dark side for over 100 days. On the other hand, except for this, there's also a problem of magnetosphere or magnetic field. The magnetosphere on Venus is non-existent, even though it does seem to have relatively similar composition to the composition of Earth. As a matter of fact, its density and its parameters are very similar, so we would expect this to have magnetic field. And we think it doesn't exist because it just doesn't spin fast enough. So, if we can somehow accelerate Venus and make it spin faster, you would probably expect things here to look a lot more Earth-like. Now, one of the reasons it's actually spinning so fast is because of its thick atmosphere. We think that over the billions of years, the atmospheric pressure here, simply due to drag, made Venus slow down its spin to the point where it's barely even moving at all. So there's several solutions to this problem, but even before I start talking about solutions, this is probably the most scientifically unachievable task right now, because removing the atmosphere is one thing, but making Venus spin faster would require quite a lot of energy. As a matter of fact, current estimates stand at approximately 50 billion petawatt hours of energy, which is approximately 1 billion times less than the entire world on Earth uses in a single year. As a matter of fact, if we were to run every single generator, TV set, computer, and PlayStation on Earth for about 1 billion years, this is how much energy we would require to basically accelerate the rotation of Venus to that of Earth. On the other hand, this is also the same amount of energy that our sun, which is right there in the distance, produces in about 10 minutes. So on one side, it's kind of a lot of energy, but on the other side, we actually do have a generator right there that can potentially create enough energy to make Venus spin faster. Now, one of the first techniques we're going to discuss here is relatively obvious. So here we're actually going to just take a look at our current rotations, 243 days. The more obvious technique is basically colliding things with Venus and basically colliding them with the side where it would actually kind of increase the rotation. And so here, okay, that actually decreased the rotation, 246 days. I put it on the wrong side. Let's try it again. Here, we're using Pallas to basically try to increase the rotation speed on it. With one single collision, it actually already improved it by 1/3. So here we have 72 days rotation speed. On the other hand, what you could actually do, and this is a little bit more realistic than just colliding things with Venus, is to launch thousands of smaller asteroids, basically redirect smaller asteroids, and make them move really fast and basically fly by Venus instead of colliding with Venus. So here, with this every single flyby, there's going to be an energy transfer between Venus and the object passing next to Venus. And if we do this enough times, we'll actually make Venus spin faster and faster. So here, an object that's relatively massive, that passes by Venus relatively close to its surface, is actually going to gravitationally influence its rotation, and as long as it passes on the right side, it's going to basically make it spin a little bit faster. So now if I take a look at it again, its rotation will have increased, or I guess decreased, to 70.3 days. So it just gained about 2 days of rotation. Or I guess it basically made it spin a little bit faster. And if you do this thousands of times, you can basically bring this down to approximately 1 day per day. In other words, you can make it more Earth-like. So that's the solution that's a little bit more realistic than just colliding things with Venus, because redirecting asteroids is not a very impossible task. We think that we are going to be capable of redirecting an asteroid in the next few decades. And so if you do this thousands of times, eventually Venus might actually start spinning faster and faster. On the other hand, if we actually launch several smaller asteroids but make them move way faster at several thousands kilometers per second, and that's of course using some sort of ion drive propulsion or something else that will increase their speed constantly, we could then use a lot less objects and also smaller objects, but would probably require some sort of a technology to have constant acceleration of these asteroids toward Venus. So that's basically a second technique, using close passbys to slowly accelerate the rotation of Venus. And the last technique I was going to discuss is, or would require something to be installed on the surface of Venus first. And here we're talking about the so-called mass drivers. These are basically, here's a picture of one. These are very large accelerators of matter. And these accelerators can often increase the velocity of something up to about 10% of the speed of light. So hypothetically, and this is actually still in the realm of science fiction, but we already have some of these on Earth, so we might as well try to find a way to create them on Venus. If you were to install a very massive mass driver on the surface of Venus, and then somehow use the atmosphere of Venus to basically get injected into the mass driver and then get shot out of it at ridiculously fast speeds, we could then maybe use these mass drivers to accelerate the spin of Venus to the point where it's going to spin just as fast as Earth. Now, this technique is definitely science fiction for now, but here's the thing. Not only will this actually make Venus spin faster, but it will also get rid of the huge atmospheric pressure. So you could technically remove all 90 atmospheres of pressure from Venus and at the same time accelerate its rotation. As long as you can create these mass drivers on the surface, this would potentially solve two problems within just about a year, maybe even less. And as long as we can actually increase the speed of Venus, we can then start thinking about everything else, including, of course, hopefully reestablishing the magnetosphere here, re-enabling the carbon exchange cycle, and creating something that seems to resemble more Earth-like features and also more Earth-like surface, atmosphere, and pressure. And this is basically, I personally think, one of the more important steps for us. As long as we can make it spin faster, we'll solve a lot of problems. On the other hand, relatively recent studies actually did show that you could potentially have terraformed Venus even without the fast spin. Using a variety of techniques such as, for example, orbital mirrors, you could project light on the other side, and using various techniques like thick cloud layers or an object placed in between the Sun and Venus in one of the Lagrange points to basically block the Sun would maybe make it a little bit easier to live on by reducing sunlight on the bright side and increasing sunlight on the dark side. Now, these techniques are still in planning, and a lot of them are still relatively theoretical, but they are possible and would definitely potentially create worlds that we could then live on in the next few millions and maybe even billions of years, until the sun expands and absorbs it. Anyway, that's all I wanted to talk about in this video, and hopefully you learned a little bit more about terraforming of Venus in it. And if you do have any other ideas about how we could potentially terraform Venus, please post it in comments below, and in one of the future videos we're going to bring it all together and possibly terraform it once and for all, creating some kind of a livable world, at least in Universe Sandbox. Anyway, I'll see you guys tomorrow, space out, and as always, bye bye.